Here we're going to look at a bunch of different examples of calculating volume, either from just shapes or from application problems. Okay. Now, in these problems here, we want to find the volume for each of the figures, and then we want to round to the nearest tenth. So one of the things that you're going to notice is that there is a figure drawn here, but that none of the information is labeled. Instead, you're given the information in words. Okay. Most of the time you would just be given this information here without the picture, so you need to make sure that you understand where and how to plug things in. So here when we're saying that the height is 5.2, we're talking about this vertical line right here, that this is 5.2, and that the radius is down here at R, and this would be 1.9. You also have to make sure that you know what the formulas are that you are supposed to be using. So here the volume for our cone is going to be 1/3 pi r squared height. And in this case, just like with most others, when we're talking about pi, we are talking about the decimal 3.14. So here we would say that our volume is going to be 1/3 times 3.14 times 1.9 squared times 5.2, and you would simply put all of that into your calculator and multiply it together, and you'll end up with 19.6 feet cubed. Now this is cubed because notice we are multiplying three ideas together. So we're squaring our radius, that makes feet squared, and multiplying by 1/3. So therefore volume is cubing it. The other way that you can remember what the power needs to be is volume is for a 3D object, so 3 for power, whereas area is for a 2D object, which would give you squared as a power. Alright, now this one is a cylinder, so again we're given height and we're given diameter. So in this case the height is 38 inches, so the height is going to be how tall it is. So this right here is 38 inches. Diameter is the entire way across, so we are talking about the entire length of this circle here. This would be 21 inches. Now, when we are working with the volume for here, we are working at pi times the radius squared height. Okay. Now there's a few things that we need to keep in mind. In this problem we were given diameter and we need radius. So the other formula you have to pay attention to is that your diameter is equal to twice the radius. That being said, your radius is going to be your diameter divided by 2, which in this case would end up being 21 divided by 2. So here my volume is going to be 3.14 times 21 divided by 2 squared times my 38. So here you should end up with the volume of 13,155.03 inches cubed. Alright, this next one is considered to be a prism. And so in this case we have length, height, and base. Okay? So when we're talking about your length, your height, and your base, we are talking about the different sides of your prism. So this line right here is going to be your height. Then when we're talking about this line right down here, this is going to be your base, and this big line right here is going to be your length. So when we're trying to label all of that in, my length is 25, so this is 25. My base was 8, and my height is 9. So with this, the volume here of my prism is going to be 1/2 base times height times length. So in this case, we have 1/2 times your base of 8 times your height of 9 times your length of 25. This is going to give you a total volume of 900, and then it is meters cubed. Okay, meters are your designation. In this one we have a sphere, and we're told that it has a diameter of 3.7. So again, diameter goes the full way across the circle, and so in this case your diameter is 3.7. So here to find my volume, we have 4/3 pi r cubed. Again, we have to find your radius. So your radius is going to be your diameter divided by 2. That's 3.7 divided by 2. So here your volume is going to be the 4/3 times 3.14 times your 3.7 divided by 2 cubed. So this is going to give you a volume of 26.5, and in this case it is millimeters cubed. Okay. Now this is considered to be a rectangular pyramid, and so in this case we have height, length, and width. So they have been labeled. H, your height, goes from the top of the pyramid down to the very center of the base, and in this case we're told your height is going to be 26 feet, and then your length is one side, which down here is going to be 22 feet, with your width being 19. To find your volume, you're going to have 1/3 length times width times height. So in this case, this would be 1/3 times your length of 22 times your width of 19 times your height of 26. That's going to give you a total volume of 3,622.7 feet cubed. Now this last pure shape that we're looking at is a rectangular solid. So again, we're looking at length, width, and height. So if we're going to label our solid, our height is 44. That is going to be this big long side here. Your length is going to be 9, and your width is going to be 5. Your volume is just simply going to be length times width times height. So in this case, we're going to have 9 times 5 times 44. So this gives you a total volume of 1,980 feet cubed. Now sometimes you're going to be given a shape kind of like this one, where you have two shapes in one, and so here you have to treat them the same as if you would break them apart. So the first thing I would do is label your pieces. We know we have a diameter of 8. So this piece right here is your radius. And so we know that if we're looking at this piece here, this is going to be 8 divided by 2, which is going to give me 4 meters. We're told you have a height of 10. So that right here is going to be this height. This is going to be 10 meters. And then we have a cone height, which is 4 meters. Okay. Once you have everything labeled, then you can go ahead and start working it. So first things first, we would find the volume of your cylinder. And in that case, you're going to have pi times the radius squared height. So here this is going to be 3.14 times your radius squared, so that's going to be 4 squared, times the height of 10. So in this case we are going to end up with 502.4 4, and this is going to be meters cubed. Now we need to find the volume of the cone, which is going to be 1/3 pi r squared height, which in this case is going to be 1/3 times the 3.14 times 4 squared. And remember, your cone height was given as 4, so this is times 4. So here we're going to end up with the volume of 67 meters cubed. Once you found all of your individual pieces, you can find your total. So my total here is going to be adding them together. So the 502.4 meters cubed plus the 67 meters cubed. This gives me a total volume of 569.4 meters cubed. Now this next one is an application, and notice it doesn't have a picture. So we're talking about a concrete foundation of a house that requires 15 truckloads of concrete. The concrete was poured at a depth of 0.5 meters and covered an area of 540 square meters. How many cubic meters of concrete were used? So here we're talking about a rectangle, so my volume is going to be length times width times height. And we can pick all that information out, because one of the things that we know is that length times width is your area. And in this case, we're told that we have an area. So this is going to be 540 times your depth of 0.5. So here we end up with a total volume of 270 meters cubed. Okay, so you have to be very careful when reading your problems to really see what it is that your problem has. Now this next part says if each truckload was the same size, how many cubic meters did each truck carry? So we know that there are 15 truckloads, and we know we have a volume. So here, in order to figure out how many each truck carried, you have to take your volume and divide that by the number of truckloads. So in this case, my volume is 270 meters cubed divided by 15 truckloads is going to give you 18 meters cubed per truck. Alright, the last one I wanted to look at here is about this grain silo, and it's in the shape of a circular cylinder that's 75 feet tall with a diameter of 24 feet. So first is to find the volume. So we're talking about a circular cylinder, so your volume is going to be given by pi r squared height. Now we're told that it's 75 feet tall, so to find your volume says we're going to take the 3.14 times the 75 feet tall times your diameter is 24 feet. So this is going to be times 24 divided by 2 squared. So in this case, your total volume is going to be 33,912, and we're talking about feet, so this is feet cubed. The next part of it says if a bushel of grain is 2.5 cubic feet, how many bushels of grain will the silo hold? So in order to figure that out, we have to take the volume of your silo and divide it by the volume of your grain. So in this case, we have 33,912, and we are going to divide that by 1.25. So in this case, we end up with 27,129.6 bushels. Now the last part says if a truck can unload 200 cubic feet of grain per minute into the silo, how long will it take to fill the entire silo? So we're looking at 200 cubic feet per minute. So first of all, we have 27,129.6 bushels. We need to multiply that by 1 minute per 200 bushels. And then we're going to multiply that by 1.25 feet cubed per bushel. Sorry, this is 200 feet cubed. And this right here, if you notice, we're going to be able to cross off my bushels and cross off your feet cubed and leave you with minutes. So this is going to give you a total of 169.56 minutes. Now we can also convert that into hours. So we can take that 169.56 minutes and we can multiply that by 1 hour per 60 minutes. And that is going to give us 2.83 hours. Now depending on what you were asked for, you can either give your result as minutes or give it as hours. However, common sense would think about doing it in hours. So do make sure you always double check the conversions that are being looked for within the problem that you are working on. So there you have it. Those are a couple very clear or good examples working with volume. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.